Hi friends, in this episode we can see about the rotary pumps. Rotary pumps types are gear pumps, screw pumps, low pumps. We'll see about the gear pump now. Rotary pump is a positive displacement pump with a circular motion. A fixed volume of fluid is moving with each revolution and can provide continuously delivered capacity regardless of the pressure. This is done by trapping liquid between the pumping elements and a stationary casing. Pumping element designs include gears, loops, rotary pistons, vanes, shuttle block, multiple pistons, and screws. Their versatility and popularity is due to in part to their relatively compact design, high viscosity performance, continuous flow regardless of differential pressure, and ability to handle high differential pressure. They can handle almost any liquid that does not contain hard and abrasive solids, including highly viscous liquids. For highly viscous liquid like a heavy fuel oil and tar, this type of pumps only will be used. Classification of this positive displacement pump rotary types are gear type, external gear, spur, helical or herringbone teeth, and lobular or impeller type, and internal gear. This positive displacement pump has two meshed gears, drive and driven gears, supported by two distinct shafts. These both are one shaft can be driven. The rotation of these gears helps the pump to suck the fluid in. The rotation of the driver and the driven gears help to transfer the fluid from the inlet to the outlet side. The fluid can't move directly from the inlet to the outlet side because there is no direct way. Therefore, the fluid must move between the gears of the pump. The tight meshing of the gears prevents the backflow of the fluid from the outlet side to the inlet side. The working of the internal gear pump is almost similar to the external gear pump. The major difference between these two pumps is that the gear pump has different sizes of the driver and the driven gears. In this gear pump, the vacuum also produces because of the gear's rotation. After fluid entry, the gear assists the fluid to move from the inlet to the outlet side and increase the desired pressure of the fluid. After that, it expels the fluid with the help of small gear. We'll see the schematic diagram in the next slide. Now we can see the schematic diagram of external gear pumps and internal gear pumps. This is a diagram of external gear pump and this is internal gear pump. This is the gear pump externally connected and this is the inlet port and this is the outlet port. Here, as we said, as we seen in the previous slide, there won't be any backflow because it is tightly meshed, so backflow will not occur. Then the fluid flows through between the gears and through the gears and the casing. It will get pressurized and coming out with the required pressure and flow. And this is the inlet gear, inlet port, and this is outlet port. This gear is meshed inside the big gear. So this is internal gear. In this also there won't be any flow coming from outlet to inlet. The rotation is like this. The inlet liquid admitted in through the port will go with pressurized condition. Like fluid like escape through this also will get pressurized and will go out. Because of the teeth there won't be any backflow to the inlet port. This is the working principles of both internal and external gear pump. Now we can see the advantages of gear pump and disadvantages of the gear pump. The advantages are these pumps are very simple and compact with very few numbers of moving parts and light in weight. The maintenance cost of this pump is very low and it has a low cost. Gear pump can be used for generating very high pressure up to 3000 psi. It can be used to pump highly viscous fluid like oils which cannot be pumped using centrifugal pumps. There are very low chances of leakage while pumping high viscous liquid like oil in the gear pump. Hence, the efficiency of this pump increases when pumping highly viscous liquids. Gear pumps can run in both directions. Hence, a single pump can be used for both loading and unloading purpose. This pump is very less sensitive to contamination. They are self-priming. See, when we see the schematic diagram, the previous slide, when you reverse the rotation of the pump, the motor, it can be used as both loading and unloading purpose. Very unique type of this, unique advantage of this type of gear pump. The disadvantages is, as meshing gears are used, abrasive fluids cannot be used in this pump. That will damage the gear. So, in when the gear get damaged, it will break and flow and pressure will get affected. These pumps are very noisy, so it will give very high sound during running. The size of the gear pump is limited, so it cannot be used for large bulk flow rates. The liquid to be pumped must be clean, otherwise it will damage the pump. So you should have the strainer, the suction filter. Variable speed drives are required to change the delivery. So we should have the variable speed motor or dyno drive motors to get the delivery pressure or flow change in capacity. They run dry, parts can be damaged because the fluid to be pumped is used as a lubricant. It is having self-priming, but if there is no flow, that will damage the gear because it will mesh very closely with each other. So the liquid which is coming as a viscous liquid coming inside, it will act as a lubricant. So it cannot be used without any flow. You should not run the gear pump without any fluid or without any liquid into the pump. This is a schematic diagram of a rotary vane type pump. This is inlet and this is the outlet. These are all the vanes and this is the casing. So this is the runner. This is a type of vacuum or suction pump. Rotary vane pump has a runner or impeller located eccentrically in a cylindrical casing or stator. This is arranged eccentrically. The impeller of the vane pump has multiple vanes that rotate according to the rotor rotation. These are all the vanes, it will rotate. During the rotation, the impeller blades trap the liquid through the housing and the impeller and releases the liquid through the delivery valve. So it will rotate. The gap between the vane and the casing will get reduced, so that will pressurize and push the liquid through the discharge like this, in this way. The impeller blades are trap the liquid through the housing and the impeller and release the liquid through the delivery valve through this discharge line. These pumps are most widely used for applications such as automatic transmission pumps, air conditioning, power steering, supercharger, braking, and high pressure hydraulic pumps. They are also used for low pressure gas purposes like chemical vapor deposition and auto exhaust emission control. You can just use it because of its vacuum and suction type. Since the rotary vane while is externally connected, while coming then the vane will go inside. During the motion, rotary motion, it will extend and during the operation the vane will extend and pressurize. While coming here, the vane will go inside to the sliding motion and it will not get rubbed. So this is the operation of the rotary vane pump. Now we can see the advantages and disadvantages of the rotary vane pump. Rotary vane pump, it has a low noise, it generates low vibration. These pumps are fully oil free. Maintenance is very easy. The vanes of this pump have a long life cycle, provide pulsation free fluid flow, can handle low viscosity fluids at high pressures, can dry run for short periods. This pump develops a good vacuum. So because of its low noise, there won't be because of low vibration. Also, it can run for dry run for short period. Without any liquid, it will run for short period, but not for long period. And it all used as a very good vacuum developing pump. The disadvantage is these pumps have low efficiency up to 30% at very low capacity. These vane pump requires pressure relief valves to prevent the pump from the sudden closure of output supply. Or recirculation line to be provided. Otherwise, the pump will get damaged. This pump needs a good seal to avoid leakage. Foreign media may cause the failure of the pump and need a good filtration system. If there is any foreign media and liquid to be pumped, that will affect it or damage the veins, that will failure the vein. So it needs a good filtration system. It has a complex design. Design is complex because the veins will extend during the forward motion and during the outer nearing the outlet. After the outlet, it will slide and go inside the vein sleeve. So the design is very complex. If it is not fixed properly, the vein will get damaged. It's unsuitable for high viscosity fluid at high pressure. Now we can see the third type of rotary pump. This is a screw type, pin screw type. This is a suction, and this is a discharge. This is a screw. Here is the pressure control valve, spindle, and there is gear in it which is used to rotate this pump. The screw pump uses one or more screws to move fluids or water along the axis of the screw. The twin screw is used here. The screws interlock to pressurize the fluid and move it inside the system. In between the screw, when the fluids come in contact, it will get pressurized and will get delivered through this discharge port. The water or the fluids enter into the pump through the inlet valve and flows linearly toward the outlet side of the pump along with the interlocking screws. The small gap between the screw and the cavity increases the fluid pressure. When fluid flows through the pump, these pumps are ideal for liquids and require a non-pulsating and steady flow. When screw pumps are running, we can get a steady and non-pulsating flow. Single screw pumps are famous due to their excellent suction capacity. They are used for many applications such as shipping, oil and gas, paint company, papers, ceramics, chemicals, etc. This pump can effectively operate abrasive and non-abrasive fluids with or without solid elements, bile, water, sludge, sewage, etc. and food, ketchup, yeast, gelatin, etc. These pumps are very low cost. In addition, the single screw pump does not clog. This can be used for any type of fluid with abrasive or foreign material like floating material in food, ketchup, yeast, gelatin, plant food, and sewage, sludge also it will handle. So it's very effective for this type of slurry type fluids, slurry type liquids, and abrasive fluids. Now we can see the advantages and disadvantages of the screw pump. First, the pumped liquid moves axially without turbulence. This eliminates bubbles created by viscous liquids. Can be used for high viscous liquid without any turbulence. These pumps have easy maintenance and need low maintenance cost. Screw pump can be used for all fluids and can run dry. Even without any flow, it can run for a long period also. Any type of fluid, slurry with abrasive material and foreign material can be used. It has a compact construction, has a frictionless rotation and have a quiet operation. These pumps deliver a constant and non-pulsating flow of fluid. It will give a non-pulsating and continuous flow of fluid. This pump can produce extended volumetric efficiency. The volumetric efficiency can be extended. High reliability, high robustness, and self-priming ability. Self-priming pump. It has high tolerance against dust particles and water vapors. Can run for liquid with water vapors and high tolerance for dust particles. Foreign materials also it can be used. It pumps the fluid with very high speed. It will run with a high speed. A screw pump doesn't pump the contamination of the fluid. So if there is any contamination in the fluid, that will not get pumped. Only the clear liquid will be pumped. It can also say for high viscous without losing the flow. It can pump high viscous liquid without losing the flow. The disadvantage of the screw pump is it is expensive to be installed for a small industries because of the close tolerance and running clearances. It is very high. Initial capital cost is very high, and it is not used for small industries. For large scale type industry only it can be used because of its cost. This pump needs a gas pellets to transfer the light gas. Gas pellet is required for this type of while used in ship. It has a very low pumping speed and worse ultimate pressure for light gases without a gas pellet. So as well when using in the ship, Because of this low pumping speed, this pressure cannot be required pressure cannot be achieved without a gas ballast. Performance characteristics sensitive to viscosity change. To change the capacity or efficiency when the viscosity of the liquid changes. High pressure capability requires long pumping elements. They are bulky and heavy. It is very heavy and bulky, so it cannot be used in all the places. Hope you might have understand the rotary type of pumps, gear type, rotary vent type, and screw type pump. Do not forget to subscribe and share it with your colleagues and friends. Put your likes and comments in the comment bar. See you with the reciprocating pump in the coming episode. Thank you very much.